Okay, in this video, let's look at some of our special right triangles that we like to use with trig functions. I've listed them here for you. We first have a right triangle that is a 45 degree, 90 degree angle, or triangle. As you remember, right here in this corner, this is the 90 degree angle. I have it set up for the sides. If we let each side be 1 and 1, using the Pythagorean theorem, we get the square root of 2 for our hypotenuse. So this is the first one. Now remember, 45 degree angle can be written in radians as pi over 4. And then 90 degrees is pi over 2. So let's put this right here, pi over 2. All right. And then the second one we have is a 30, 60, 90 degree triangle. Let's see, 60 degrees can be written as pi over 3 in radians, and 30 degrees is the same as pi over 6. Okay, we have it set up where our sides are 1 square root of 3, and if we use the Pythagorean theorem, we can get 2 for our hypotenuse. Now let's just evaluate some trig functions. Over here in the right corner, I just relisted our trig functions in terms of a right triangle. So let's look at the first, sine of 30. So we can come over to our triangle, find 30 degrees. Remember, sine is opposite over hypotenuse. So if we go to this second triangle and find 30 degrees, which is right here, our opposite side would be 1, and our hypotenuse would be 2. So the sine of 30 is 1/2. Let's look at number 5, cosine of pi over 4. So let's go up to the first triangle. We have pi over 4 is the same thing as a 45 degree angle, and we know that the cosine, right, is adjacent over hypotenuse. All right, so for 45 degree angles, our adjacent side would be the side 1, and our hypotenuse would be the square root of 2. Okay, so many times we can just write it this way, but a lot of times they may ask you to rationalize the denominator. If we do that, we need to multiply by the square root of 2 over square root of 2. Remember, our goal here is just to get rid of the radical sign in the denominator. So by doing this, we get square root of 2 on top and 2 on the bottom. So cosine of pi over 4 is square root of 2 over 2. Okay, let's look at number 6. Tangent of pi over 6. Let's come over to this second triangle and find pi over 6, which is 30 degrees again. We know that tangent is opposite over adjacent. So looking at this triangle, the opposite side would be 1, and the adjacent would be square root of 3. Okay, here's another example where we need to rationalize our denominator. So always when we rationalize, just multiply by the same square root. We get square root of 3 and then over 3. And there's our answer. Okay, let's look at number 7. Now we're getting to where we are talking about cosecant, cotangent, and secant. They're reciprocals of our sine, cosine, and tangent. So for number 7, for cosecant, we want to first find the reciprocal, and then we can flip it. So if you remember, if you look at the top, cosecant is the reciprocal of sine, right? They go together, so they're inverses of each other. So we're going to first find, we're going to find the sine of 60 degrees, right? Then flip. So find sine first, and then we know we can just flip it to get cosecant. All right, so the sine of 60 degrees. We know sine is opposite over hypotenuse. All right, so we go over here to 60 degrees. The opposite side would be square root of 3. All right, the hypotenuse is 2, so that's the sine. Therefore, the cosecant of 60, we would just flip it, 2 over square root of 3. Now let's rationalize it just in case you may have to do that at some point. So that would be square root of 3 over square root of 3. And that will give us 2 square root of 3 over 3. That's our answer for the cosecant of 60 degrees. Okay, let's move over to the far left side, number 7, the secant of pi over 3. So just like the last one, let's find its reciprocal first. So secant and cosine go together, so let's first find cosine, and then we can flip. So let's find cosine of pi over 3, right? Then flip. All right, cosine of pi over 3. Cosine is adjacent over hypotenuse. And let's come up here. Pi over 3, right here in the triangle right above us, pi over 3, the adjacent side would be 1, and the hypotenuse would be 2. So the cosine of pi over 3 is 1/2. Therefore, if we flip it, the secant is 2 over 1. Let's see, secant of pi over 3 would be 2 over 1, or just 2. All right. Okay, one more. We have a little space here. Cotangent of 45 degrees. Let's first find tangent of 45 and then flip. All right, the tangent of 45 degrees. We know tangent is opposite over adjacent. So if we go to the first triangle and we choose one of the 45-degree angles, the opposite is 1, the adjacent is 1. Therefore, we get 1 over 1. And if we flip that, we get 1.